When we have large numbers where maybe it's not quite as easy to use the intersection of sets method or the prime factorization method, we can use the Euclidean algorithm method to find the GCD of the two numbers. So the idea here is that if I have two whole numbers a and b where they're both positive and a is bigger than b, then the GCD of a and b is equal to the GCD of r and b, where r is the remainder when I divide a by b. So the process looks like this diagram down below. I'm going to start with my numbers a and b. I'm going to divide the larger number by the smaller number. If my remainder is 0, then the last divisor is my GCD. If it's not 0, I'm going to continue dividing. I'm going to divide the divisor by the remainder, and I'm just going to keep repeating until I get to a 0 remainder. So let's see that in practice. This is called the Euclidean algorithm. Alright, so I want to use the Euclidean algorithm to find the GCD of 10,764 and 2,300. So I'm going to start by dividing 10,764 by 2,300. When I do that division, I get a quotient of 4 with a remainder of 1564, right? This is my remainder. And so the Euclidean algorithm says that the GCD of the two numbers I started with is the same as the GCD of my divisor with my remainder. And so now I'm looking at the GCD of two smaller numbers. I don't have 0 as a remainder, so I'm going to repeat this process. So now I want to divide 2,300 by 1564. I get a quotient of 1 with a remainder of 736. So I can replace that GCD that I was looking at with now the GCD of my divisor, 1564, and my remainder, 736. That's not 0, so I'm going to continue. When I divide 1564 by 736, I get a quotient of 2 with a remainder of 92. So I can again say that my GCD is now equal to the GCD of 736 and 92. And I'm going to divide again. So I want to divide 736 divided by 92. I get a quotient of 8 with a remainder of 0. So my last step here says that the GCD of 736 and 92 is equal to the GCD of my divisor, which was 92, and the remainder, which was 0. And we saw in the last video, we did it for 13 and 0, but in general, for any number with 0, the greatest common divisor is just that non-zero number. So in this case, 92. So the GCD that I was originally interested in is 92.